Hello everyone, myself Vaibhav and today I'll be talking about a project JPEG image compression. Firstly, modern devices handle large raw images that slow down storage and network transmission. Traditional compression methods fail to balance speed, size and quality. So there's a need for efficient, optimized compression techniques for photography, web media and streaming. Understanding JPG compression. Firstly, we will reduce the image size using lossy and lossless techniques. Secondly, we will convert RGB to YCB-CR to separate brightness and color for better compression. And we operate on 8x8 image blocks to simplify processing. Compression pipeline. Firstly, we will convert RGB to YCB-CR for better human visual efficiency. Block division, we will split the image into 8 blocks. Then we will convert pixel into frequency components. Lastly, we will quantify, that is, we'll remove less important frequencies with major size reduction. Finally, at final stage, we use lossless entropy encoding. We give shorter codes to frequent values, reducing file size. We also encode both DC and AC coefficients efficiently, which essentially for compact storage and fast transmission without altering image quality.
I'm going to tell about understanding mechanism of Huffman coding. First, we calculate the frequency of each symbol. Next, we create a min heap to easily access the symbol with the lowest frequency. Finally, we build the Huffman tree by repeatedly merging the two least frequency nodes. And this is our pseudocode overview. This pseudocode explains the entire JPEG compression process. It includes RGB to YCBCR conversion, dividing the images into blocks, applying DCT, performing quantization, zigzag scanning, run length encoding, and finally Huffman coding to produce compressed bitstream. And the features of Huffman coding is a lossless final stage. DCT and quantization remove unnecessary frequency components. Run length encoding compress the long sequence of the zeros. This is combination of forms the standard JPEG method used in most devices. And this is our C++ implementation code. This program loads the image, takes the quality value from the user and saves the compressed JPEG using the GDI plus encoder. It shows a practical implementation of how JPEG compression is performed in C++. And these are our out. Here are the we can see the program output and the image results. This is the input image and this one is the output image. The compressed image has a smaller file size while still maintaining the visual quality similarly. This clearly demonstrates the effectiveness of JPEG compression. And in summary, JPEG combines DCT quantization and Huffman coding to achieve high compression with good quality. This makes JPEG one of the most efficient, widely used image compression methods. And thank you.